Hi, today we're going to look at the PAT 2016 paper going through question 12. So in question 12, we're told that a ball of mass 100 grams bounces, and that whenever it bounces it loses 1/4 of its kinetic energy. And we're asked if it's dropped from 1 metre, after how many bounces will it be unable to reach a height of 0.25 metres? Okay, so what we ask ourselves is, how much energy must this ball have to reach 0.25 metres? So we have some ball falling and rebounding, and it's going to reach some height h after each bounce. So we want h to be equal to 0.25 meters. Well, we're going to assume that the only energy it has when it's rising and falling is kinetic and potential energy. So when it gets to the top, it's going to have 0 kinetic energy. But we want it to reach a height of 0.25 meters, so it's going to have potential energy. So we're going to try to find the potential energy it had at 0.25 meters, and that will therefore be equal to the kinetic energy it must have when it rebounds, such that it can reach the height. Because all the kinetic energy it has at the rebound will be converted into the potential energy. So to reach 0.25 meters, it will require mgh, which equals to the mass, 100 grams, times g10 times the height, 1 meter, which is equal to 1 joule of energy. So it requires 1 joule of energy to reach a height, oh sorry, not 1 joule of energy, my mistake there. We want it to reach a height of 0.25 meters, so that's a height of 0.25, which is 0.25 joules. So we require a kinetic energy of 0.25 joules after the ball rebounds from one of its bounces. So if the kinetic energy after a rebound is less than 0.25 joules, it will be unable to reach a height of 0.25 meters. So let's try and consider how much energy it starts with. So it's going to be dropped from a height of 1 meter, and it's going to strike the floor with the same kinetic energy as it had potential energy when it's dropped. Because all the potential energy will be converted into kinetic. So if we find the potential energy it has when it's dropped, that will be equal to the kinetic energy it has when it first hits the floor, just before it hits the floor. Okay, so initial potential energy is equal to mgh, which is the mass times g, and it's dropped from 1 meter. So that's 1 joule. So it starts with 1 joule of energy. So that means it strikes the floor with exactly 1 joule of kinetic energy. So what we're going to do is we're going to let UN be the kinetic energy the ball has after the nth bounce. Okay, so what's U1? What does the ball have after one bounce? Well, it's going to lose 1/4 of its kinetic energy. So that means it's going to be left with 3/4. And it strikes with 1 joule. So what's 3/4 of 1 joule? Well, that's clearly 3/4 of a joule. And what about after the second bounce? Well, it's going to go up to reach a potential energy corresponding to 3/4 of a joule, come back down, have kinetic energy 3/4 of a joule, strike and lose 3/4 of that. So that means U2 is going to be equal to 3/4 times 3/4 of a joule. Similarly, U3 after the third bounce will be 3/4 times 3/4 times 3/4. So this implies that UN, the energy after the nth bounce, will be equal to 3/4 times 3/4 to the n minus 1, which is our definition of a geometric sequence. So we require, so this here is the energy, the kinetic energy it rebounds in after the nth bounce, and we need that to be less than 0.25 joules for it to not reach the height of 1/4 of a meter. So in other words, we have, well, 3/4 times 3/4 to the n minus 1 is simply 3/4 to the n. So we have 3 to the n over 4 to the n is less than, well, 0.25 is 1/4. And therefore, times into by 4 to the n, we want 3 to the n to be strictly less than 4 to the n minus 1. So let's consider those values. So we're going to have a n column, we're going to have 3 to the n, and we're going to have 4 to the n minus 1. So we can have n being 1. What does that correspond to? Well, 3 to the 1 is 3. 4 to the 1 minus 1 is 4 to the 0 is 1. 2, 3 squared is 9. 4 to the 1 is 4. Okay, so we carry over. N is 3. 3 cubed is 27. 4 squared is 16. N is 4. 3 to the 4 is 81. 4 to the 3 is 64. And then carrying on further, we haven't had that 3n is less than 4 to the n minus 1 yet. What about n is 5? Well, 3 to the 5 is 243, but what's 4 to the 4? Well, that's 256. So we see for n is 5, we have 3 to the n is strictly less than 4 to the n minus 1, which is the condition we require for the ball not to be able to reach a height of 0.25 meters. And therefore we see it's after 5 bounces.